Welcome back. In this chapter, we'll be talking again about linear and quadratic equations, only this time we'll be thinking about them as being functions. So in this section, we'll be talking not just any old linear equation, but a linear function where y is a linear function of x. So any linear function will have this form, f of x equaling mx plus b. Remember that when we're thinking about f of x representing our function of x, f of x itself is our y value. So when I say f of x is equal to mx plus b, I'm really also saying the equation is y equals mx plus b. That's one key takeaway throughout all of this, is that whatever we have as our name for our function, that's representing our y values. So f of x equals mx plus b, our y values are whatever comes out of f of x. And so we know right away for this that y equals mx plus b, that's a line with a slope of m, and it has a y-intercept of 0b. So if we wanted to, we could graph it or do any sort of thing that we'd like with it. We also know that the slope of our line tells us whether we've got a graph that's increasing if the slope is positive, or decreasing if the slope is negative, or horizontal if the slope is 0, so constant. So any sort of linear function that we can look at, based on its slope, we can then decide whether it's an increasing graph or a decreasing graph or a constant graph. Any function that's not a linear function we would call nonlinear. So, for example, a quadratic function would be nonlinear. A function that involves square roots would be nonlinear. Anything that's not an equation of a straight line, any function that's not the equation of a straight line would be a nonlinear function. Now, there is one little question that I have here, which you might have been wondering about. Which is that when I talked about slopes, I said we had things with positive slopes that were increasing and negative slopes, those were decreasing, and lines that had a constant slope of 0, that was a horizontal line. You might have wondered, well, what about the vertical lines? And so for that, even though a vertical line, the equation of it would be a linear equation, it wouldn't be a linear function. And you might wonder about that for a minute. Why am I saying that a straight line that's vertical wouldn't be a linear function? The key to remember here is that in order to be a linear function, you first have to be a function. And remember that in order to be a function, the graph would have to pass a vertical line test, that any vertical line that we draw would pass through the graph in exactly one place at most, never two or more places. Now, if you're thinking about a vertical line, if you were to graph a vertical line and then think about drawing the vertical line that passes through that graph, it doesn't just pass through one point, it passes through all of the points. So a vertical line would not be a function, and because it's not a function, then it can't be a linear function. All right, so for our first example here, we have f of x equals negative 3 halves x plus 2. And so we know that's representing the equation of the straight line y equals negative 3 halves x plus 2. So we know that the slope here is negative 3 halves, and that the y-intercept should be 0, 2. And of course, because the slope is negative, then f of x is decreasing. All right, so easy enough. And now I guess the one thing I maybe would like to do next would be to graph f of x. And for this, you can do it in a bunch of different ways. I mean, you can start by finding x and y intercepts and then connecting the dots. And I'm going to use the y-intercept and the slope here to do my graphing. I'm going to start with my y-intercept, which was the point 0, 2, and then I'm going to use my slope. So I'm just going to remind myself here that the function that we're graphing is negative 3 halves x plus 2. So I have my y-intercept of 0, 2 already plotted. And next I need to remind myself that for this slope of negative 3 halves, that means that for every 2 units that I go to the right, I'll be going 3 units downward. That's what the negative slope is telling me. So from that point, 0, 2, I'll be going 2 units to the right, and then 3 units down. So the next point that I would plot would be this point that I've circled, negative 1, 2. So now let's plot that point, and I'll label it before I forget. Notice, of course, here that I've got, as always, my x-axis and my y-axis labeled, and I've also got my tick marks labeled, and I've also got all of my points labeled. That's the ideal here, that we want to have everything as well labeled as possible. And of course, as well, I've got the equation of my graph labeled. So there we go. That's f of x. F of x being negative 3 halves x plus 2. Okay, couple of functions here. We have f of x equals 3x minus 2, and g of x being negative a third x plus 4. A couple of things just before I do any of the problems in part A and part B. One thing that you might notice about these two lines that we're graphing, these two linear functions, one of them has a slope of 3 and the other one has a slope of negative a third. And so one thing that we should remember from the previous sections is that these two lines should be perpendicular. So, spoiler alert, we're going to be graphing both of these lines on the same axes at some point, and so when I do that, you'll see that these two lines should meet at a nice 90-degree angle. But back to the question itself. The first part was just solving where is f of x equal to 0, and if you're thinking graphically, what is this telling us? This is telling us the x-coordinate for the x-intercept. So if we were solving f of x equals to 0, what we're finding here is where do we cross the x-axis. So 3x minus 2 equals 0, 3x equals 2, and then x is 2/3. So my solution set has just one point in it, 2/3. And of course, that means that if I were graphing f of x right now, I would know that it has an x-intercept of 2/3, 0. For the next part, part B, solving for where f of x is greater than 0, that's asking ourselves for, whenever we graph our line, where is it above the x-axis? Because, of course, f of x represents the y values. We're looking for where are the y values greater than 0, where are we above the x-axis? And I'm just going to solve this like any inequality. 3x minus 2 is greater than 0, so 3x is greater than 2. Dividing by 3, since I'm dividing by a positive number, that does not change the direction of my inequality. So I find that x has to be larger than 2/3, so for my solution, it would be the interval of everything that is larger than 2/3, not including the 2/3. So round bracket around the 2/3, going all the way to infinity. So that means that whenever we get to graphing, we should see that our line should, number one, cross the x-axis when x is 2/3, and that when we are to the right of 2/3, this line should be above the x-axis. And now, same thing with g of x. We have negative a third x plus 4. We want to know where that's greater than 0. And this, of course, is telling us where is g of x above the x-axis. So negative third x greater than negative 4. Here I'm going to multiply both sides by negative 3, and that means that's going to change the direction of my inequality from a greater than to a less than. So here x is less than 12. So all the values less than but not equal to 12. Those would be all the values of x where g of x is greater than 0. So that means that when we graph g of x, when we get into graphing that function, we're going to find that for all the values of x that are less than 12, that's where our line is above the x-axis. Of course, remember here that, again, g of x greater than 0 is the same thing as asking when are the y values greater than 0. Okay, last part here on the page, we're looking for f of x equals to g of x. And you'll notice I keep going back to thinking about what does this mean in terms of the graph, and that's because we're not just interested in the mechanical side of being able to solve. In fact, the solving f of x equals g of x, that's kind of easy enough for me to do, but it's nice to also know what does that mean? Why are we doing it? So if we're thinking about this, f of x is representing the y values on that line, and g of x representing the y values on that line, what we're wondering is, where do the two lines have the same y value? In other words, where do the two lines cross each other? That's what we're going to find here. When we have our two equations that we graph, f of x and g of x, they are going to cross at some point, and not a surprise. We already said that they should. They're perpendicular lines. They will meet somewhere. And when we find when f of x equals g of x, we'll be finding the x value for where these two lines are equal to each other. In other words, we'll be finding the x coordinate for where the two lines cross. So let's do that now. If we want f of x to be equal to g of x, then 3x minus 2 needs to be equal to negative a third x plus 4. And now all we need to do is solve for x. So I'll bring that third x to the other side and bring the 2 to the other side. I will have 10 thirds x equals to 6. And then I can find, using my calculator, multiplying both sides by 3/10 or dividing both sides by 10 thirds, however you'd like to think about it, you'd find that you get 18/10, which is the same thing as 9/5. So when x is 9/5, these two functions should have the same y value. And so the second part of the question, what is the value of f of x and g of x for this value of x? We want to know what's the corresponding y value. And you'll find out that f of 9/5, that would be the y value when x is 9/5. Running that through your calculator, you'd find that that's 17/5. And you should get the same thing for g of x. G of x should also give you 17/5. Because, of course, you were finding where are these two functions equal to each other. Where do they have the same y value? And yes, indeed, they do have the same y value. And that y value is 17/5. So that means that if we're graphing f of x and g of x, we now know a bunch of things. In particular, we know that they're going to meet at the point 9/5, 17/5. Okay, so now the next part for us to do is to graph our lines. And we're going to graph them on the same axes, so that means that when I graph these lines, I need to make sure that in addition to plotting their points and labeling their points, I need to also label the equations of the lines. This is part of the reason why I keep stressing labeling the equation itself. And that's for these sorts of instances where we might be graphing more than one thing on the same axes, and so we need to be able to tell which function is which. Okay, I'm going to start with f of x, and for f of x, just as a reminder, we had that function was 3x minus 2. G of x, just as a reminder, that was negative a third x plus 4. So when I'm going to graph these lines, I'm going to do it in the same way that I did the last one, using my y-intercept and my slope. So for f of x, it has a y-intercept of -2. So it passes through the point 0, -2. And it has a slope of 3. If your slope is 3, that's the same thing as 3 over 1. In other words, for every 1 unit you go to the right, you should be going 3 units up. So that means if we go 1 to the right, and 3 units up, then the next point on our line should be the point 1, 1. And now I'm going to draw my line. And label it. So I'm going to label its coordinates 1, 1, and I'm going to label the equation over here, f of x equals 3x minus 2. And there we go. I have my first equation now taken care of. Second one, graphing g of x. Now, same thing. This has a y-intercept of 0, 4, so I've got that. Good. And now my slope of -1/3 telling me that I'm going to be going across 3 to the right and down 1 unit. So from that point, going 3 units to the right and down 1 brings me to the point 3, 3. So that means that the second point on my graph of that line should be 3, 3. And now I'm going to draw my line as best as I can. Label my coordinates, and then there we go. And you can see here, even with my not the best drawing by hand in the world, I still get something that looks roughly like it's perpendicular lines. The last part, of course, here was labeling the point that represents the solution. Now, before I do that, of course, I should label my second equation. G of x is -3rd x plus 4. I almost forgot to do that. Of course, we want to make sure that everything is labeled. So I have my equations labeled, I have their points labeled, and here the other part that we're going to label is this point of intersection where the two equations cross each other. And that's supposed to be at 9/5, 17/5. There we go. All right, so here's one where we have an equation not given, but we have the graph of the equation. We have the graph of f of x given, and I do happen to have 2 points on the line that are labeled. And in fact, you've got 4 points. You have a y-intercept and an x-intercept. So if you really wanted to, you could generate the equation of this function, but you don't really need it. Because for all of this, for parts A, B, C, and D, really all we need to do is look at the graph and understand what the question is asking. In part A, it's asking for where is f of x greater than 0. And as always, I remind myself, this is referring to the y value for that function. So where are the y values greater than 0? Well, all over there. And where is that? Well, that's for all of the x values that are less than 4. If our x values are less than 4, then our line is above the x-axis. So where is f of x greater than 0? Everything up to, but not including 4. I'm not including 4 because that would be where f of x is equal to 0, and I'm not interested in it being greater than or equals to. I'm interested in it being strictly greater than, so 4 would not be included. For the next part, part B, where is f of x equal to 3? So in other words, where is the y value 3 on this graph? And you can see that it's right here, that the y value is 3 when x is 0. So the only solution for where is f of x equal to 3 is 0. For part C, we want f of x to be between 0 and 3, including the 0. So we're looking for the y values to be between 0 and 3, going from 0, including it, all the way up to 3, not including it. And we can see that that would be this part of our line here. That would be the part of the line that has a y value that's between 0 and 3. And so that happens between x values of 0 and 4. At the x value of 0, that's where we have a y value of 3, and we're not including the 3. So when it comes to my interval, I won't be including the 0. For the 4, on the other hand, that's where we have a y value of 0, and we are including the y value of 0, so that means I do want to include the 4 here. So my interval would be all the numbers for x between 0 and 4, not including the 0, but including the 4. And now finally, we want f of x to be less than or equal to 2. In other words, we want the y value to be 2 or less. And so if we're looking at our graph for a y value of 2 or less, that would be all of this part of the line, which is all of the line that happens when x is larger than 4/3. So we're going to be looking at all the values of x that are 4/3 and larger. And as far as 4/3 goes, I will include 4/3 because that is the point where the y value is equal to 2, and I am including the 2. So since I want the y value to be equal to 2, that means I do want to include the point 4/3, 2. So I do want to include that value of x. So square brackets 4/3 all the way to infinity.